Hello students, welcome back. Let us look back at the Rutherford's experiment now. So this is the source of alpha particle. This one is the slit. Alpha rays are going on to hit this target. This is the gold foil, 0.004 millimeter thick, and that is this screen, this semicircular screen is the zinc sulfide coated fluorescent screen. So the position of the particles after passing through the foil was ascertained by the flash produced on a zinc sulfide screen. Okay, so this zinc sulfide screen, Rutherford asked his young scholar Marsden to see if any alpha particle could be scattered through a large angle. What Rutherford expected was simple small deflection. Actually most of the particles passed through the gold foil without any large angle scattering. Only one, you see in this picture, only 1 in 20,000 particles, large scattering was observed. When Rutherford was asked, he said that it was almost incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you. Clearly, particles must have been scattered because there was some positively charged heavy mass inside atoms which repel the positive alpha particles. And this encounter took place once in 20,000, only once in 20,000. So this proved that the core is very small in dimension compared to atom's dimension. Thus the existence of positively charged nucleus was proved. Rutherford's model was thus a negative electron circulating about a positively charged nucleus, and the orbit is circular. Rutherford termed this circular pathway as orbit, like the solar orbit, like the planetary orbit, etc. And why electrons are revolving and not falling on the nucleus? So Rutherford's logic was that is due to balancing of this inward attractive force towards the nucleus acting on the electron and the centrifugal force on the electron due to revolution around the nucleus. Okay, so this keeps the electron stable in this orbit. So far so easy. But then James Clerk Maxwell's classical electromagnetic theory created the big problem. Electrons, charged particles, they move in a circular orbit. Let us assume with a constant speed like this, but its direction is changing continuously. So also the velocity of electron is changing with time. That means acceleration of electron, because change of velocity with time is called acceleration. So electron is accelerating when it is revolving around the nucleus. So what? So Maxwell's classical electromagnetic theory says that in such a case, electrons will emit radiation. That means they will lose energy continuously, so that the distance from the nucleus will decrease continuously, and ultimately it will fall onto the nucleus along a spiral pathway like this. Boom! Rutherford's atom would thus get destroyed. Okay, so while all these analyses were going on, discovery of atomic spectra of different elements brought the second problem for Rutherford's atom. Spectra, in singular noun, it is called spectrum. Spectrum is obtained when we unmix some composite radiation like white light by passing it through a prism. More sophisticated instrument is spectroscope. Light coming out from heat excited solid or liquid elements like this one, the tungsten filament, produces a continuous spectrum in the spectroscope. But light from hot gaseous elements, or light after passing through cold gaseous elements, gives discontinuous spectrum. Since gaseous elements are nothing but atoms of elements, we can thought of as bunch of atoms, as a colony of atoms. So those spectra are called atomic spectra. Now think about Rutherford's atom. So since this software I am using permits only 10 minutes video to capture, so let us discuss about Rutherford's atom and spectrum problem in the next video. Okay, kindly follow me. Thank you.